Hello YouTubers! In this video we'll be covering Octave, a scientific programming language like MATLAB that's mainly used for numerical computations and machine learning. So if you head over to the GNU website, you can download it for whichever OS you are using. Once you've downloaded it, you'll get two things, Octave CLI and Octave GUI. CLI is like a command prompt where you can enter Octave commands, while GUI is more like an IDE. We'll be using the CLI for the remainder of this tutorial, although you can use the GUI just fine. So, each line we enter commands to tell Octave something to do. We can add numbers, we can multiply numbers, we can subtract numbers, or we can divide numbers. Notice how Octave prints out the result each time we do these operations. If we don't want it to print out the result, we put a semicolon at the end like this. We can clear the screen anytime by typing in CLC and pressing enter, and the screen will get cleared. Next, we can use variables to store the results of these commands. For example, we can do a is equal to 5 plus 5. Oops. We can even do operations with these variables. So for example, if I create another variable b equals 10 times 5, I can do d equals a plus b, and this will store the results of a plus b in another variable called d. Now the special part is that we can store vectors and matrices. We surround the elements in brackets like so. If we want to add another row, we do a semicolon. If we want to add another column, we have to use a comma or a space. And you see that we have created by a 2 by 2 matrix. We can create a vector of evenly spaced numbers by using a colon, like this. We can specify the spacing between them by doing something like this. If we want to transpose a matrix, which basically means to rotate it in 90 degrees clockwise, we can use a single quote. So if you set a to 1 to 10, and if we do a single quote, you'll see that it gets rotated 90 degrees. It becomes a column vector. Let's move on to some inbuilt functions now. They're basically built-in tools that we can use. For example, we can create an identity matrix by I equals 4. It creates a 4 by 4 identity matrix. There's another one called rand, which will create a matrix of elements who will range from 0 to 1. We can also specify the column and the rows. So rand 3 by 5 will create a 3 by 5 matrix. There's also zeros, a equals zeros 4, which will basically create a matrix of zeros by the specified dimensions. If you ever want to know more about a function, you can type in help zeros, and Octave will print out information about the function. By now you have noticed the parentheses we use in functions. Let's create a random matrix. If we want to access the element, we can do it by its index. Basically, the index starts at 1 and it goes down. So 1, 2, 3, 4, 5. So if we access the fifth element, you'll see that we get this. We can also access it by the row and the column. So if we do a second row, second column, we'll get this element. We can use a keyword called end to get the last element right here. We can also do a end minus 1 to access the second to last element, this one. We can do this in the row and column notation, so a end minus 1, end minus 1. And you'll see we get an element from the second to last row and second to last column. If we want to get a whole row, we can do something like this. The colon means all the values in the column. We can even convert a matrix into a column vector by just using a colon. We can add elements to A by doing something like B equals 1, 2, 3, 4. And then we can do A semicolon B. And you see we add these values to the bottom. If you want to add it to the side, we can do A space B transpose. But you'll notice it won't let us do this because the dimensions match. So to correct this, we can do A, B, and get just the first three elements, transpose n matrix. And you'll notice that it works. If you want to get the maximum value, we can do something like max A. And you'll see that we get the maximum value of each column. If we want the maximum value in the entire matrix, we can just repeat this. So we can do max of the maximum of A. And this will give us the maximum in the entire matrix. If you want to get the matrix row-wise, we can do max A empty matrix 2. And you'll see we get the maximum row-wise. We can get the size of a matrix by doing x comma y equal to size of A. What this will do is store the rows in the matrix of A in x and the columns in y. We can also perform operations on matrix. Let's create a new vector A equals 1, 2, let's say 10, and transpose that. We can add 3 to each element. We can multiply each element by 5. Or we can divide each element by 10. Now we can multiply two matrices or vectors if the rules of matrix multiplication are followed. The columns in the first matrix must be equal to the rows in the second matrix. So for example, if you create a second vector b equals 1 to 10, and this will be a horizontal one, we can do a times b, and you'll notice that we get this big matrix. This is the result of the matrix multiplication between A times B. Now we can do element-wise element by the corresponding. For example, if you said A is equal to 1 equals B transpose 10 transpose, we can do A dot, and we do A is equal to A divided by 10, which will just multiply. Now we said B corresponding element to there. So the 1, 0.1 will be multiplied by 1, 0.2. We can do A dot times B, which is not matrix multiplication but element-wise multiplication. You'll see that 0.1 gets multiplied by 1, 0.2 times 2, and so on until 1 is multiplied by 10. We can do logical operations on vectors. For example, we can set A is equal to rand 5. Now what we can do is C is equal to A greater than 0.5. Wherever an element in A is greater than 0.5, C will be set to 1. Now we can calculate the number of elements in A greater than 0.5. We can do sum of C, which will give us the per column sum. So we can do sum of C, and there are 14 elements in A that are greater than 0.5. Now the ones and zeros represent booleans, where 1 is true and 0 is false. Now we can compare values by using if statements. If 5 is greater than 10, you'll notice that we can write another line. We'll set, let's say, E equals to 10, else we'll set F is equal to 10, and we press N. So you see that F was set to 10. That's because 5 is not greater than 10, so the value, or the command rather, inside this was executed. Notice the AND keyword used to specify that the if-else statement has ended. We can also type something called WHOS, whos, and we can get a list of all the variables that we have created so far. You can see the number of elements we have and the data space they're occupying. We can also type in who, and we'll just get the name of the variables. We can clear variables by doing clear A, and now if you type who, you'll see that A got deleted. Let's move on to for loops. If we want to repeat command, we use them. So let's say A is equal to 1 to 10. Then we can do something like for I equals 1 to 10, I is equal to I plus 2, and you'll see that each time that we went through the loop, the values got changed. Each time this statement was executed, Octave printed out the updated A vector. We can see it goes from 1 to 3, 2 to 4, 3 to 5, and 4 to 6, and so on until it went from 10 to 12. Let's move on to plotting. There are some issues with the CLI version of plotting, so we will use the GUI version instead. To plot, we simply type in the x-axis and the y-axis. So plot 1 to 5. This should give us a linear graph. And we see that we've gotten one. If you want to add a title, all we do is title. And now if we check it, the title has been added. We can plot more complicated graphs. For example, we can do x minus 7 to 7. And we can do y is equal to sine of x. And then we can do plot x and y. Now you'll notice that it's a very crude graph. It's because we only have a gap of 1 between each x value. So we can change that by doing x equal to minus 7 and 0.0127. Y equals sine of x. We get a lot of values. And then we do plot x and y. And you'll notice we get a cleaner approximation of the sine graph. Plot multiple graphs on the same plot. We can do x equal to minus 10 to 10. Then we can do plot x and x to get a linear graph. Then we can type the command hold on, and we can plot x and sine x. And if you notice, we get a sine graph with a linear graph. We can type in the command legend and do linear, and we can write sine. If you notice, now the graphs are labeled. Finally, we can add a title. Notice the quotations used for text, and you can see a title has been added. We can also disable hold on by typing in hold off. We can now plot histograms. We can do something like x equals rand, let's say 10. And now we can do hist x. And you'll see we get a histogram of the values. We can create our own functions, and they require their own separate files. So head over to new script. We type in function to denote it's a function. Result, which is the value returned by the function, equal to calculate result, and we can type in a value x, press enter, and then we can simply do result is equal to x times 5. Now you have to save this file. I'm in a folder called Octave scripts, and I'll name this calculate result. Now if we head over to the command window, we can type in calculate result. Let's pass in a value 125. And you see that the function worked. Note you have to be in the directory that you created the function in order for this command to get called. Next, let's move on to while loops. Let's create a variable called I equals 0. Now we can do while I is less than 5. I is equal to I plus 1, end. And you'll see that it started at 0 and it got increased by 1 each time inside this loop until it reached 5, where the loop stopped functioning. This wraps up the fundamentals of Octave and the tutorial. In the next few videos, we'll be creating machine learning algorithms using Octaves. See you guys soon.